So next, I want to welcome Andrew Fair, who's the director of the Population Health Data Hub.
So this is an interesting transition from a presentation about global representativeness of literature now to a GIS project looking at geographic information systems. So I'm Andrew Fair from the Population Health Data Hub. And it's really a QI project about improving methods, replicability, reproducibility, and standardization of research methods in a institutional geocoding tool. So first, what is geocoding? If you don't know, geocoding means taking an address, like 123 Main Street, and corresponding it with a place on a map, usually a latitude and longitude coordinate pair. So like anytime you enter an address into Google Maps and you get a point on a map, that address is getting geocoded on the fly. So an example of this is if you were to look up in Google Maps 550 First Avenue, you would get back a latitude-longitude pair. It would be 40.74266 north of the equator and 73.97386 west of Greenwich. That's an example I just geocoded. Didn't know I could do it. Geocoding, it's critical to research for several reasons. A very common one in population health research, which is the space that I work in, is joining an address to its neighborhood characteristics, like from census data or American Community Survey data, to say this person lives in a neighborhood characterized by such and such economic variables, educational variables, things like that. It can also be used for cluster and hotspot detection, analyzing distance and travel time. For instance, if you want to look at access to care in terms of how far people need to travel or how long they need to travel to get to a point of care, and of course, for making maps. So why did we want to take on this quality improvement project? There were several motivating factors that we encountered here when we started this about 4 or 5 years ago. One was security. People were putting patient addresses, which is PII, into internet lookups in order to geocode them. That is a bad idea. Don't put PII into a search engine that's unsecure. So we wanted to get around that, and we wanted to standardize processes because everyone was kind of making it up on the fly, looking up processes on their own, making their own determinations, and no one really knew where to go for central guidance. So we wanted to create something reliable and something more efficient as well, so that every research team didn't have to reinvent the wheel every time they wanted to geocode a set of addresses. So what was our solution? We found a wonderful vendor called Geocodio, and we did a vendor review. We compared to among several various options, and we found what we thought to be the most accurate, the most affordable, just the best to work with vendor. And we selected them, and we undertook an on-premises implementation in close collaboration with a great team from MCIT that supported us. And now we have a full instance of Geocodio, their whole web platform, what you would use if you went to their website. We have the whole thing installed on an on-premises server that gets updated quarterly. And so you don't need to ever leave the NYU secure network if you want to geocode addresses. And we institutionalized this. Now it is the preferred practice, the preferred process. If you go look up geocoding on Inside Health, you will be routed, I think, to our portal, our geocoding portal. And so no one has to guess which is the best way to go. This is a vetted and sanctioned geocoding process. So what did we actually create? How do people use this? First of all, the easiest way to use the service is with a point-and-click CSV uploader. So a CSV file, it's like an Excel spreadsheet, basically. You can just drag and drop it into our interface, hit go, hit a few more buttons than that, but not too many, honestly. Just hit a few buttons, hit run, and it will geocode all of the addresses in the list and give you back all the information that you want. That's the easiest way. For people who want to integrate geocoding into their coding processes for an analytic process that they do, that they're working on, we have an API as well that you can hit. You can integrate it right into your code and set all the parameters exactly the way that you want with all the control that you could want in your code. And this is all entirely free for users here at NYU. That was another thing I guess I forgot to mention, but people are also paying for geocoding processes that they found. And so now we have something free for all NYU users. But besides this, we realized that most of the time people were geocoding Epic patient data. You could geocode all sorts of data that you might have, but usually that was the most common use case, the Epic data. So why have everyone do that over and over? Instead, we again worked with the MCIT team to create a scheduled weekly process where all the Epic patient data gets geocoded. Really, it's the delta. Any new data gets geocoded. And that runs, like I said, weekly, so that no one ever has to do that again. It just happens automatically. And not just current patient address, we also geocoded all of the change history of a patient's historical addresses, as well as point of service, point of care addresses that are in Epic. And we put this previously into Hadoop, now into Databricks, which is now our big enterprise data system. And it's in a database that anyone can access, and we have instructions on how to join it easily to the Epic patient data. A few other goodies that we get along with the basic geocoding information, it's what Geocodio calls data appends, just extra fields that you can get back. Like I said at the start, oftentimes people geocode to join to neighborhood level data, like from the US Census Bureau. So instead of making them then fetch that data and do an extra join, we've loaded a bunch of that in already, and Geocodio actually makes some of the basic fields available straight through their own platform, some of the more commonly retrieved fields. We give all of the census geo-identifiers, so if you want the numerical code for the precise city block that someone lives in New York City, we have that code there that you can then join to external data sets. Also, other things, legislative district, congressional district, which is kind of getting increasingly relevant now. Other, metadata fields like accuracy reports on how confident the geocoding algorithm is that it got it right, because it's never really 100% confident, right? It's hard to know precisely where an address falls, and different vendors will have different algorithms, but each vendor will have its own sort of confidence determining algorithm. So it can say, I'm 99% certain that I got this right. And in fact, not only am I that certain, but I'm certain that it was down to the rooftop point level on a map, that's how precise it was, as opposed to, say, the zip code centroid. You get all of that information back. And so an analyst might decide to set a threshold and say, I only want rooftop level of accuracy at a confidence level of 95% or above. That's all that I deem reliable enough, and they can set that cutoff right in their code. And you also get back the standardized and formatted address string. So if there are any spelling errors, any other sort of formatting errors in the address that was the input, you get back the corrected formatted output. What are a few use cases? We've had so many, but I picked some that I had nice maps to represent. And these were great projects, honestly. One team, actually we supported this team that was evaluating the Sweet Truth Act. This is a New York City policy to display, I think it's highly sugar sweetened or foods with a certain threshold of sugar in them. I think it's like more than 1 day's allowance, I think is what it is. That needs to be revealed. It needs to be disclosed to the consumer. So they wanted to evaluate that, and in order to do this, they needed to compare New York City restaurants against similar restaurants in Chicago. And so we geocoded them and did a clustering process in order to create sort of pseudo neighborhood comparisons between New York City and Chicago. Another team, I think this was the Rapid RCT team, did some emergency department utilization modeling, and they needed to look at where new ED visits were coming from. And so they used the geocoding data in order to do that sort of forecasting. We track all of this. We've gotten a lot better at this over time. There's a lot on this slide, but my colleague Chuan recently created this wonderful dashboard that shows all the geocoding processes. The things I guess I'll point out are that over 99% of all of the Epic addresses have been geocoded, and you can see at the bottom the accuracy rating on that. So almost 90% accuracy across those 99% that have been geocoded. And also, it gets challenging, honestly, to count the number of addresses that people are using, but we estimate it's on the order of many millions if you consider all of the queries against the geocoded Epic data, plus all of the CSV uploads we've had. It's millions and millions of utilized addresses. And just closing remarks, this was a project that standardizes an important analytic process, and we think it helps to promote replicable research methods. And for us in the Pop Health Data Hub, I think that our guiding light, our North Star, is trying to make research easier for the researcher here at NYU. I want to thank the fantastic team behind all of this work. There were so many great contributors. Ian Gonsalves is in the back there. He was our key MCIT colleague who helped set up the databases. And Chuan, who you see first here, she's out of town today, unfortunately, but she created most of the interface that all of this builds upon, that it operates upon here, and everyone else that you see. Thank you.